Hello, hello. Well, thanks for the wait. We already were capable of finishing the details. So now we're going to go with the panel entitled Empowering the Geospatial Workforce for Tomorrow. Please give an applause to our panelists. Yes.
Do I get a microphone?
I think there's one down there. Do we have? ¿Tenemos otros micrófonos por ahí? Ah, sir, you have one.
Gracias. Good morning, everybody. Thanks for staying with us. Change in schedule, working through the technical difficulties. It's great to be here. I feel like my microphone is breaking out. Is this better if I hold it up here? Still breaking. Can you hear me now? It's breaking out, isn't it?
Can you
Break.
get it closer to you?
Closer. Does this work better if I hold it up here? Still breaking out. Still not.
Better. Okay, yes, come here, please.
All right, how about this? Can you hear me now? Yay, thank you, Miriam. All right, well, good morning, and again, thanks and welcome for being here for this panel. We're excited to talk through empowering this geospatial workforce of tomorrow. We've got an exciting panel. We've got Roberto who's jumping in at the last moment. Thank you very much. I'm going to just do a couple opening remarks before we get started. And actually, I'm going to shamelessly, as the moderator, take 2 minutes to talk about a project that we're opening up because I've not gotten up here and talked with you at all. And I wanted to share this idea with you, this new project that we're working on called Sustainable Geocommunities. And the idea is, this is going to look familiar to a lot of you. This is an initiative that our university, University of Minnesota, I should have said that. I'm Len Knie from the University of Minnesota. We're interested in looking at local problems and global impacts. It's based a lot in geodesign. Who's familiar with the term geodesign? Not too much. All right. It's GIS. I think I would argue that it's another way of framing what we do a lot of. It's just through a different lens. Carl Steinitz, who coined the term, or one of the people who coined the term, probably would not agree with what I just said. But that's okay. It's my choice to do that. And it's the idea of taking what we do, our geospatial technologies, and combining that. You can see the overlapping circles there with information technology. So using the tools and the resources that we've been hearing about throughout this conference, taking the GI sciences, taking the design professionals, right? Because they have a really important approach in how they look at problems, right? If you think about design theory and design thinking, it's a really great way to approach it. And then the core piece of this is involving the people in the place. If you're going to do research, if you're going to do work, you've got to include the stakeholders. And I would argue that sometimes, at least in my university, they're not thought of as they're planning, as we're planning research projects. So we're trying to address that and to have this Sustainable Geocommunities initiative. It's actually just getting off the ground this month. And we're looking for collaborators. We've been collaborating with universities in India. So the IITs, the India Institutes of Technology, as well as Amrita University have been our first partners. I should also mention the University at Buffalo, which is part of the SUNY system, State University of New York. But it's open globally. And I'm not going to go into it too much because the panel's not about this, but I did want to mention that we have seed grants available. The QR code will take you there to get some more information about the seed grants. They're not small, they're not large. It's about $100,000 a year for 3 years. We plan on funding up to 4 projects. And the letter of intent, which is a simple letter of intent, it's not a 5-page letter of intent, it's a couple paragraphs saying, what do you want to do? If you go to this link, you'll see examples of different projects of what people are thinking about. One requirement for this project is there has to be a University of Minnesota faculty member involved in that. That's something that I'm here, and if any of you are interested in looking at this collaboration, that's part of my job, is to help make those connections. So if this sparks some interest in you, we've been looking, I'll give you just a couple quick examples, looking at issues of water, issues of energy, waste. I'm wearing my SDG pin today, right? You can map a lot of this to the SDGs. But through a geospatial lens. That's the geo within geo communities. So I'll stop there because, again, that's not what this panel is about. But if you do have any questions, I'm happy to talk with folks anytime while we're here. So we have an amazing panel of 5 people who are ready to talk. I can tell. I can tell they're ready to go. So our idea here is that our charge for this session is to look at what tools, what skills, what we can do in the academic community to prepare our students for exciting jobs and careers in the geospatial field. There's a lot of work to be done. I'm going to give you a spoiler alert here. We're probably not going to solve the problem of how do we get people ready for all the jobs that are in geospatial. But we can have a really good conversation today, and I'm excited to hear what our panelists are thinking about. I just grabbed this quick snapshot from the web this morning. Here's the global geographic information system market. I would argue that this is grossly underestimated. This is looking at people who are doing GIS, and if you look at the top players in the market, it's Esri, it's Hexagon, it's Pitney Bowes, Trimble and Autodesk. And right now they're estimating, or in 2022, about a $9 billion with a B in US dollars in the market. And they're looking at that more than doubling by 2030 to over $23 billion. And the reason why I say it's underestimating it, the market is looking at the core geospatial technology, the people providing the services, the people providing the software, the data creators. I would suggest that GIS, spatial thinking, location analytics, whatever you want to call it, is used in most domains, in most disciplines, throughout companies, throughout nonprofits, NGOs, higher education, throughout the world. GIS is part of just about every industry that is out there. So there are a lot of jobs, there are a lot of opportunities, talking to the students. Get excited about geospatial. It is going to be part of the future. All right, with that, we are going to take, I should just lay out what we're going to do today. We've asked each of the panelists to take 5 to 10 minutes to introduce themselves, talk about their work, anything that they'd like to share with you. So we'll do that first. Then we'll open it up for questions. Be thinking of your questions as our panelists are talking. We do have up to 90 minutes to be part of this panel. So we want you to be involved and ask them really, really hard questions. Because I just get to moderate. I have the easy job tonight. So, Diana, would you like to? Do you want to? Either way. Did you?
Buenos días. Good morning, everyone. My name is Diana Gabriela Castro Frontana. I'm a teacher at the National Polytechnic Institute, and what brings me here today is my experience in GIS, but how that experience started. So, well, I'm an environmental engineer. I went to Germany in 2001 to do a GIS traineeship. And there, that year marked an important milestone in my life, because as an environmental engineer, I never thought that I was going to be involved in this world. Let me tell you that during the 5 years of the environmental engineering studies, I had no idea of what GIS was. I didn't have any course about that. Then I went to Germany, and they put me in front of a computer. And I went to the Rostock University, and there was the Geoinformatics Institute. So they put me in that office, and when I arrived there, they told me, okay, you have a book about GIS, about ArcView at that time. And then they put me in front of the computer and say, just train yourself, because the next day we are going to do like field work. And I was like, I don't know anything about this. I mean, it was in English, it wasn't my mother tongue. I had to learn by myself, but I had to do it because the traineeship was going to last 4 months there. So I had to learn very quickly. So I started reading the GIS book, and that's the way I got involved in the GIS world for the first time. I had no idea that in the following years I was going to be working on that, and that I was going to get in love with GIS so much that I still keep working and applying GIS to the environmental studies that I participate. So then I went to study a master's degree in environmental engineering and in sustainable infrastructure in Sweden. My master thesis was about connecting cloud forest conservation and GIS. And then coming back to Mexico, I worked at several companies in the private and public sector. And then in 2010, I started working for the National Polytechnic Institute at the National School of Biological Science. So that was an introduction. And is that it, or we start with the... Okay, yes, sure. I'm going to address this question. How can we, educational institutions and industry partners, yes, you tell me, collaborate to ensure geospatial professionals are well prepared for emerging challenges? Where I think one solution that we have to address is that, as he mentioned, there is a huge market for GIS professionals. But nowadays we have like a market that is divided in these 3 parts, like GIS courses. We have many, maybe some of you offer GIS courses by your own, but many of them have no state regulation or supervision. Another way to bring or have more people prepared in this matter is through formal education in universities. There, we can adapt GIS courses to the needs of different careers, like in my case, to environmental studies. And another one that I would like to discuss later in more detail is the use of competency standards, which is a way of formal education. It's a very different education that is cheaper and is shorter than like college courses. So the good thing about the competency standards is that they are recognized in Mexico, US, and Canada. And in Mexico, just as a matter of fact, see here, we have what is called the National Registry of Competency Standards, the RENIC. So you can go to the webpage at conocer.gov.mx, and you will see about this system, the formal education, a short but valid formal education. And the RENIC is like a catalog where you can find all the competency standards that describe a set of knowledge, but also abilities, skills, and attitudes that you require to perform an activity in the labor, there is the reference, it's also the reference that allows you to evaluate competencies, and if applicable, you can obtain also like a certificate that supports your experience. So just to give you an example, we have in Mexico, we have approximately 500 competency standards, but only 2 of them are related to GIS. So we need more. In the United States, they have like 65,000 standards. I don't know how many of them are related to GIS, but in Mexico, we only have 2. That means that there is no standard for certification that is valid or that is recognized by our educational system that is related to GIS. So we will need to work together, the academia, industry, companies, to create new competency standards. And that's one thing I can introduce about the need of more GIS professionals.
Thank you, Diana. Originally, we're intending to have Carla as part of the panel, and she is not able to be with us today, and we've been having some technical difficulties getting her on. If she's
I'm
listening.
here.
You are here.
Yes, and I see you.
Ah. Well, welcome, Carla.
Thank you.
Let me back up a little bit and get onto the slides. It's great to have you here and to join the panel. I'm going to turn it over to you to talk a little bit about yourself and anything you'd like to share with us, and let me know when you want to advance slides.
Of course. Well, thank you, everyone. As Len has explained, it's sad that I cannot be there. I tried. I was at the gate trying to get to the plane, but migration status is a tricky thing to have. Anyway, my name is Carla Saldaña Ochoa. I'm an assistant professor for artificial intelligence in architecture at the University of Florida. I've been working with artificial intelligence for the last 8 years. So when I was asked to participate in this panel and to reflect into, or at least suggest what are successful case studies that show this interdisciplinary collaboration with geospatial support centers and researchers, I thought I will give you a little bit of a background of how I see this collaboration to happen. So the first slide that you're seeing here on the screen is the way that machine learning, or let's say the way that artificial intelligence has been explored in the last 50 years. So there is 2 research areas. The first one that is called, that is towards logic or rule-based models, and the other one that is towards neurosimulation. So up until 1980, the branch that was towards rule-based and logistic or logic-based was having a lot of success because we were able to encapsulate a lot of complexity in models that were following rules. Like an example of this is the machine learning model logistic regression. But what happened at the early 1990s is that, 1990s, is that the approach of towards neurological simulation had a sprint because we had computational power, and also there was the implementation of something called artificial neural networks. And they were also exploring 2 ways. The first one is researchers wanted to understand how the brain works, so therefore they fell into biotechnology and bioscience. And the other one, which is creating an abstraction to represent how a neural network works. And that's how they created this probabilistic or probabilities-based approach. In the next slide, what we see is that up until 1996, this is a book published by Stuart Russell and Peter Norvig, both considered the grandfathers of artificial intelligence. Peter Norvig was involved in the algorithm that is behind Google. They classified artificial intelligence in very specific research areas. So there was expert systems which were working with numerical data. We have computer vision, which was trying to make a computer see, which was basing on images. We have natural language processing, trying to make our machine understand language. And so this is all about text. We have robotics, which was a software hardware implementation. And then we have machine learning. If you see, this is before the 2000s, when research areas were very siloed and we had specific data that was being used to run specific models. And you see that also these two research areas, from the logic-based and the neuro-based or probabilities-based, are also well-defined. What happened right now? And that's on the next slide. What's happening right now is that we're seeing this cross connection between all of these different research areas in artificial intelligence that have been overtaken by machine learning. What this means is that artificial intelligence is such a great umbrella of different research applications that very currently has been overtaken by machine learning. And what is machine learning? Machine learning is one application of artificial intelligence that learns from data, or at least it's an automatic rule follower. That's an algorithm that gets input data, process this data, gets an output, and the output influences the input data, right? So that could be doing classification, prediction, generation, and so on. And here it goes, the answer to the question, like, what are successful cases or case studies that we have interdisciplinary collaborations that leverage these geospatial support centers. So what we see here is that expert systems are collaborating with natural language processing, and this is when they created ChatGPT. We see that computer vision and natural language process are combined, and this is when they created this generative image-based algorithm. And one of the examples that we could see here, for example, is the creation of finding correlations that have to do with space. And this is an example that I'm going to talk in my next lecture. Is we're trying to find a correlation between health, housing, and hazards. All of these three great topics have geolocated information, which means that we're able to pair them or to be able to correlate them because they are all represented in space. Before the 2000s, there was a siloed approach to different research areas, and now we have the capability to be able to have a multimodal encoding. What that means is that we don't have to think only in a silo way. We can leverage technology of today to be able to encode all of the different data formats into a meaningful data representation, which in this case is going to be rendered in space. So, in the next slide, I think, so what I'm showing here is the typical process of a machine learning approach, right? So there are different ways that a machine learns. So there is supervised learning, there is unsupervised learning, there is reinforcement learning, there is semi-supervised learning. All of these entitles that there is a specific focus on three stages on the process. The first stage, I call it teaching, which is about the data set. In the case of supervised and unsupervised learning, and in the case of reinforcement learning, this is all about creating the policy and identifying the rules. The middle stage, I call it learning, and that's the place where we have the algorithm selection. And the algorithm selection needs to be specific to the type of data and to the type of questions we have, and then we have the inference. Why am I showing this connection here? Is because I want this process to have a human-centered approach. That means that the human is involved in the teaching, is involved in the learning, and is involved in the inference. Because for some time we thought that the human was much more relevant in the inference phase when we had to validate the output. But what I'm proposing is if we want to have a interdisciplinary collaboration, we need to leverage everybody's knowledge in teaching, learning, and inference when we're working on a project that is dealing with technology and with machine learning. And I think the last slide, this is a snapshot of what the research lab that I'm the director. So I ran a lab that is called the SHARE Lab, which is Spatial Human-Centered AI Artificial Intelligence Experimentation. So the QR code will lead you to our website, but mostly what we're thinking of is first, when a project comes to our lab is, do we really need artificial intelligence? And if we need artificial intelligence, how can we make a process where we have a teaching, learning, inference, human-centered approach to solve the problems that we have? And here we have two research areas as well. One that is working with social large-scale urban data sets. These are mostly geo-reference data sets. So here the geospatial analysis is quite relevant. And the other branch is about working with artificial intelligence to empower creativity thinking or creative thinking. So these are the two realms that we're working on. And I just want to do like this little pitch. If you're interested in collaboration, or if you are interested into thinking about how to create human-centered AI approaches to different data research areas, I'll be happy to collaborate. All right, that's me, and I hope I answered the question.
Perfectly. Thanks, Carla. We're going to keep moving on to our next panelist. Christoph, would you like to come on up?
Thank you, Len. I'm very happy to be here about this panel. I would like to start a few words about me, my story, and also somehow the story of GIS, making a sort of parallelism in between the two. And I would like to send a message to the students: believe in you, and to my young colleagues in GIS, believe in you as well. And I will explain that. And to the students, especially. My parents were in Spain, and in 1940s, in the past millennium, in Spain, my name is Claramun, so buenos días a todos. They crossed the frontier, the French-Spanish frontier. They lost everything. At that time, in the 1940s, computer graphics were coming up, and the world were changing. GIS did not exist at that time. Our family was working hard, and then I came up in the 1960s. GIS still didn't exist at that time. Probably the first time GIS, Geographical Information System, started to exist was with the term Geographical Information System. And this is something very specific to Geographical Information System, and now is going to Geographical Information Science, is a very only example where science started by systems and then evolving to science. And this is quite unique because in comparison to many other scientific domains, first of all, a specific scientific domain is starting by science and then systems. This makes a big difference. I was born and I worked quite hard, and I came up to the Swiss Federal Institute of Technology in theoretical computer science, which is somehow boring. And there I discovered a group much more interesting than computer science. The group was involved in geographical information system. And at that time, a journal was starting in 1989. The journal is called the International Geographical Information System and then Science. Believe in you, I was looking to this journal. Wow, this is impressive. High-level research is done in this specific area. So I get interested. And then my career developed and so on. I made a PhD in theoretical computer science, applied to, well, spatial problems. And then I moved to different labs in England. I have been partly in Canada as well. And over the 30 years, I've been also a researcher in geographical information system and then science. I've been in China, I have been in Japan, I came back to France and so on. And now I'm one of the editors of the International Geographical Information Science. Just to say that believe in you as far as you are interested by a specific domain, and geographical information system of science is very much exciting. Why it is exciting and difficult? It is a new domain. It is one of the very few domains whose boundaries are not very much defined. If you take electronics, it's a very old subject. Microtechnique, telecommunication, all of them are very much well defined. The problem with geographical information science, and maybe the chance we have, is the subject is very large, not very well defined, and every year we do have new topics coming up. And as you are a student from computer science, this is very much exciting. Big data is coming up, did not exist a few years ago. A large language model are coming up, did not exist a few years ago. Sensors are coming up. So what I want to say is that this domain of geographical information system is really a hot domain of many opportunities. In terms of impact, 80% of the information is spatially related. This means that many opportunities are coming up. The domain is fun, comparison with many other, let's say, a computer science subject. Over the past 30 years, I have been working with people in transportation, in geography, in environmental sciences, in urban sciences, in graphics, and so on, so it's really exciting. And the problem we have to deal with are also related to what we call the blue planet. So now with the experience I have been gained over the past, let's say, 30 years, I am chairing this new project, which is a $30 million project for 10 years, where the objective will be to dealing with the blue planet, environmental issues, and so on. How to move the slide? You know, I'm a computer scientist, but I have still problem with techniques. Okay, now, after this brief introduction about my story, and really, you have to believe in you, because at the time I was born, GIS did not exist. At the time I started as a young researcher, wow, and now, well, I did it, so you have to believe in you. What about my previous colleagues were talking about AI? It's not a new trend in geographical information science. Recursively, AI is coming up. When we think about geographical information, and as you are computer scientists, computer students, computer engineers, when thinking about information, we first have to integrate, to model, to represent, to manipulate, to analyze, to visualize the information. How useful can be artificial intelligence in relation to geographical information system, especially in relation to education. At the data integration level, the key issues to deal with are how much useful AI could be for a better integration of these big data which are coming up from different sensors, from different places, from different area, urban, environmental, and so on. So probably AI is likely to be very much helpful in the way the data can be integrated, because we are talking about millions of data, not very well formatted, coming up in real time and so on, with different mechanisms. Data modeling. Early today, we had a great presentation on the use of large language model for generating knowledge graph and extracting geographical information from textual data. Surely, artificial intelligence is likely to be very much useful to structure the data automatically, to provide much more mechanism to access the data, of course, and as You have been probably, all of you, using ChatGPT and other systems. AI is likely to be very much useful in the way we can interact with large language model and so on. AI is also very much useful for annotating very large depository of data, whatever the data form, can be textual, can be image, can be video, and so on. And as students, I'm pretty sure you are already using those large language models to generate, let's say, some textual information well structured and even chapters and so on. And this is a key issue in education. Code generation, AI is getting fantastically interesting as far as the system can now generate programs for you, complex code and so on. So the world is changing, and AI, driven by the industry, and this is another difficult subject to deal with, as teachers, we have to take into account the fact that these systems are developed by the industry, and we don't have all the inputs to be part of it and to have interaction with this system. Impact on education. I set up 3 terms in terms of the knowledge levels and course and phases that should be considered. I mentioned that the impact of GIS is very large. Environment, urban application, hydrology, marketing, health, and so on. Depending on the application, the level of knowledge is very likely to be different. My main, let's say, discourse will be to say, first of all, the way GIS should be developed in terms of education will be in relation to specific domains. And every domain will have some specific constraint to take into account. Technology. The technology of GIS is very large, from sensor, organizing, structuring the data, and so on. This is a second level. And the concepts behind the way the information can be represented, stored, manipulated, and so on, those 3 domains, according to the people we should teach, should be considered in order to define the most appropriate level to consider. So in fact, my keywords will be, we should take into account who is being taught, what is being taught, and for what purpose is being taught, including not only artificial intelligence, but GIS and overall. I strongly believe that nowadays teaching should be problem-based, should be based on case studies, and especially with a close relationship in between research and education. As teachers, we are often researchers, and usually the best teachers are often involved in research to make connection, but not only research, but also, and this is an excellent trend here, the team, Carlos, Miguel, and Roberto, they do have close connection with real problems. I saw wonderful application here dealing with crime, pollution, health studies, and all these domains are very much connected to what I'm saying, a close integration in between research, real project, and capability that really cover many subjects, including artificial intelligence. Thank you very much.
Thanks, Christophe. Director Him, come on up.
Hello, everyone. What a fantastic speakers right here, panelists, and Len is doing a great job, so a round of applause for Len. I know he's going to give me a hard time. So let me just give you my introduction. I'm very impressed and excited with the names here in Mexico. So it's Diana, Gabriela, Castro, Fontana. I thought that I don't have that long name, so I should just put it in a title what I do, just to compensate. No, I'm just kidding here. So what I do, I work with NYU. My background is in architecture, urban design, urban planning. I did my urban planning from NYU, and I work with NYU. I head a unit called Research and Instructional Technology, and then in that there is a unit called Data Services, okay? Let me just go through a little bit of context of NYU. So NYU is the largest private university in New York, and in USA, and it's one of the most applied to school in the country. We have about 65,000 students. We have 3 campuses throughout the world which are degree granting. So main one is in New York. We have a couple of campuses within New York, Brooklyn, Manhattan. Manhattan, we have a few of those. We have one in Abu Dhabi, very well established, in Shanghai. And then we have about 12, what do we call it, centers throughout the world. And these are in almost all continents. We have Buenos Aires, Paris, London, Sydney, Tel Aviv, you name it. There are a lot of those centers. And our students come from around 133 countries, okay? In New York, there are more than 100 languages are spoken, and then NYU is also kind of representing New York in that sense, that we have a lot of diversity, okay? So this is a busy slide. I apologize, but this is the money slide, okay? So NYU Data Services is where I work. It is a joint facility between NYU IT and NYU Libraries, okay? And there is an advantage in it in the sense that we have technology and we have subject experts in one room at the same time. So I have about 11 colleagues, staff members, and then we hire about 15 students to work for us. And our main agenda is to enable, foster, and support data fluency. When I talk about data fluency, that means also GIS, okay? It's included in it. And what we want to do is we want to foster data-driven research and scholarship at NYU. That's the main agenda, okay? So we have a lot of panelists who are amazing researchers, and we saw a lot of projects. So we are the unit that actually supports them in doing this research, right? In enabling and become like a catalyst. Our main framework is research, supporting research data lifecycle. So what it means is that if you want to collect data, you want to find data, you want to access data, we can help you with that. If you want to clean data, you want to analyze meaning you want statistical analysis, geospatial, you want qualitative data analysis, we can help you with all of that. We can also help you with data visualization. A lot of time, researchers need understanding about how to manage their data, right? If I was one of those a person who used to label the file as final version of my files, that's not the best way to store your data or your files. So we have experts who can help you manage your data for the long term, right? We do a lot of data preservation, geospatial data preservation. So if you are doing some cool research, you want that data to be preserved for long term and to be used by your other colleagues, we can help you with that, okay? So this is our framework. On the right side, if you see it, these are our services, right? So we do consultations, about 3,500 consultations per year. Instructions, about 250 courses we teach. We do boot camps. We do course integrated sessions, meaning let's say your faculty member want us to come and teach, let's say, geospatial in R or Arc Pro. We'll come and teach that so that students get more engaged, more contextual learning, okay? We have a computer lab which has very high-powered computers, so we help researchers do hand-holding, do coding, do mapping, visualization, all sorts of help with that. We also distribute a lot of software, geospatial software throughout the university. And then we support research, and then one of the things we do is we do outreach like GIS Day. GIS LATAM is one of those examples, right? So even though this slide is very busy, I'm gonna still show you some geospatial images, what we do, okay? At the very bottom, you cannot read it, but these are all the fields we have supported or we are still supporting. So NYU, even though it's so large, we don't have a geography department. We don't have geospatial program. That's why my unit becomes very important for the entire university. So we have supported urban planners, we have supported data scientists, we have supported politics, people in politics, applied psychology, applied statistics, conflict resolution, you name it. Almost every field you can think about have used GIS, okay? It's a very powerful tool. And the topic of this panel is about how can we empower you guys, right? So this is where, if you believe in geospatial support services, like Felix opened this amazing new center, I think this is where this is also your asset. Yeah, you should also feel like, hey, I want to contribute and make it more useful for others. How can I help my peers? How can I help my other students also learn more, right? So this is your asset also. So feel proud and also promote that space. This is kind of a visual of what we do. And we have, GIS Day, so we host a lot of talk series. We do mapping competitions, user map galleries. We sometimes feature augmented reality sandbox, a new technology using AI and other stuff, and that's just make it fun. So learning is also equally fun. If you take an opportunity like this in GIS LATAM or any other conference, participate, challenge yourself, go outside your comfort zone, and that's where you will learn the most, and connect with any of us to help you answer any of the questions you have. Okay, thank you.
Thanks, Him. Our next panelist is Director Angie. Put it there for you.
Thank you, Len. Thank you to everyone for the invitation to be here. My name is Angela Lee, and I'm with Esri. I'm part of the team that supports educational institutions. So my colleagues and I help introduce people, students, researchers, faculty, the people that operate educational institutions. We help them to understand the potential of GIS to benefit their work. So our big idea is we want to help create a prosperous, equitable, and sustainable future, helping people apply a geographic approach to understanding, so in research, creating new knowledge, and solving the world's challenges using GIS. And so many people have talked about the value of project-based learning, this idea of, hey, let's apply GIS to issues in the real world, not just think about things theoretically, but actually applying things to make the world better. So I am from Minnesota. I actually graduated from the University of Minnesota, but it was so long ago that Len was not yet at the university when I was a student. But I live in Minnesota, so Len and I get to interact quite frequently. I had no idea that I would be a geography major. When I was starting school, I didn't really know what I'd do, and a friend of mine during orientation week said, I'm taking this geography class. Do you want to take it? And it was right at the time that cartography was becoming computerized. It was right at the time that GIS was being introduced in education. And so I studied geography and urban geography and thought I might become an urban planner. But as I went through school, I got more and more interested in GIS. And so I've been at Esri for a long time. And it's wonderful because the field is always changing. There's always new things to learn. And working with people in education who are very curious and wanting to learn things, solve new problems, means that my job is never boring. So at Esri, our education program, we support people in K-12 schools, in colleges and universities. We have programs to work with students directly outside of the classroom setting. We also work with informal educational institutions like museums, and we also work with people who manage facilities at universities or manage enrollments and trying to, find enough students for institutions. So it's the entire breadth of what educational institutions do. We divide our work into kind of 3 big areas. So outreach, talking to people, helping them understand that GIS might be valuable for their work. That includes doing things like participating in conferences like this. Probably the biggest part of our work is creating resources or connecting people to resources. So books, online training, workshops, just things that will help people learn how to use GIS effectively. And then another big piece, of course, is software. So providing software. Actually, a very interesting part of the job is talking to people about how they would like to use software. Where are the gaps in what the capabilities of Esri software currently, where are there gaps? Where do people have ideas for how to make the software better? So it's engaging in conversations, not just to tell you, oh, you should use GIS, but hey, help us make GIS better by sharing your ideas of what it should do or what new things you would like to be able to explore. So that's my introduction. I'll hand things back to Len.
Thanks, Angie. All right, we now have met our distinguished panelists, and it's time to do questions. I think we have about 30 minutes or so for questions. I'm hoping that you're thinking of some questions. I'm going to challenge students. I hope you'll come up with a question for our panel. Question or opinions. Let's hear what you're thinking about, right? We're talking about how do we empower the geospatial workforce of tomorrow. That's you. And we need to hear from you what you think is important, as well as our amazing panelists who are with us up here on the stage today. I'm going to do the first question, and then we'll come to the audience and see what you're thinking about, and if you have questions. So I'm giving you one question to think about, or for time to think about what is important. And question number 1, what key skills and knowledge areas do you believe are essential for the geospatial workforce of tomorrow, to have a geospatial literate workforce? And I'm going to say, let's not bring AI into this right away, because I promise you the next question will be about AI, because I think we're going to spend some time talking about it. It's important. It's a game changer in what we're seeing with the geospatial world within GIS and GI science. So what other important areas are there for students, graduates, and people working in the geospatial workforce? Angie, can I start with you?
I think I'm good. Okay, thank you. Sure, Len. So I think the best piece of career advice I ever heard was that your technical skills will get you your first job, but other things like your work ethic, your interpersonal skills, soft skills are what will determine how you advance. So I do think that technical skills are important, and certainly, if you're wanting to go into the geospatial industry, an understanding of geography and some basic computer principles are important. Christoph, you talked about, or actually I think it was you, him, talking about file management. Maybe multiple people talked about data management, file management. I mean, those really are some fundamental skills. I think at this point, having some basic understanding of coding is important. In some ways, it's less important which language, and just more important that you understand how to break a problem down, how to structure and test code, things like that. I definitely think some basic statistical literacy is important. Communication is always going to be an important skill, and I would add graphic communication to that, as well as written or verbal communication. I think really knowing how to communicate things through visuals effectively is a skill that will set you apart. In terms of communication skills, I think one thing that I see a lot of people lacking is the ability to synthesize and summarize a lot of information. So to take a big amount of information and get down to the essence of it and communicate that clearly so that people aren't confused. They don't have to read through, tons and tons of information to get the key idea. Oftentimes, you will do a big project. You will put a lot of effort into it, but at the end of the day, what your boss wants is just a summary. Like, what was the bottom line? So learning how to summarize and synthesize, just give people the key information first, and then let them ask you for questions if they need more details, is a skill that I find very useful. Again, as you progress through your career, you most likely will be responsible for managing projects, managing other people. And so one skill that I wish I had really mastered or learned earlier is project management. Learning how to really estimate how long things are going to take so that I can plan my work and plan the work of other people accurately. And that's something where, start small, start with a research paper, then do a little bit bigger project, then do projects with multiple people. That's where it gets really interesting, is when you have to coordinate with multiple people. And then maybe the last idea I would give you, an important skill, is be willing to experiment and innovate. Try to look at ideas across different disciplines and see how they might relate to what you're doing. I think often the most interesting work happens at the intersection of disciplines. I mean, some people love to go really deep into a particular topic, but I think as the GIS industry grows, where there will be growth is in applying GIS in new ways, in new areas. And so being willing to learn a little bit about an adjacent field, mix ideas from two different fields, be willing to take little risks, and then iterate, try something. If it doesn't work, make adjustments, try again, but be open to innovation.
Thanks. Other people on the panel want to address this? Tim.
So it seems like Angie stole all my notes. Well, I don't want to repeat, so I will just touch upon or reiterate only a few of them. So yes, I think tool-based learning will wear you out. But if you have sound kind of concepts or core concepts or methods, today it is Python or ArcPy, tomorrow there'll be something else, you can easily transfer the knowledge, right? The other, I know that we're not supposed to talk about AI, but there is one thing you will encounter again and again, and I think pay attention, is how to use AI in more effective and ethical way. You will always have to look into that aspect, okay? And critical thinking. Just don't take it for granted that whatever is presented to you, whether by machine or otherwise, it's all correct and true or gospel, right? You have to question that. And along with the presentation, storytelling through your data and analysis is very important. Thank you.
Thanks, Tim. Carla, you're on. If you want to respond to this, please do. Thank you. Questions? Yes.
I'm sorry, it's just my computer frozen. I wanted to.
Oh, please.
Yes. Let me turn on my camera. I have 3 screens, and I was trying to have you in the larger, but I have to deal with the small screen right now. I think to bring to the conversation as well the ability of to storytelling. I think this is something that I realized when teaching is that the project gets better understood if you have a strong storytelling background. And I think about storytelling is the ability to create a narrative that allows students to present the question, right? Create a strong problem statement, and then take you through the whole process up until the end of the results. And of course, I will answer this by training yourself into a vocabulary to create like I will say an artificial intelligence literacy, which means that you're not fearing what is being thrown to you from other fields where this is a common knowledge. So I'll say literacy doesn't really mean getting to know to code from the very beginning, but it's more about understanding what you're reading and not being, not to reject before you clearly or at least comprehend what it's being presented to you.
Thank you. Thank you. Here.
Thank you for giving me this opportunity to share a Canadian perspective on what we want. Doesn't work?
Is there another microphone? Oh.
Okay, so I wanted to just, in reaction to this question, bring a perspective from Canadian side and also my own experience in terms of education. So myself, I'm from geomatics, and what we learned through our education, it wasn't necessarily started with developing systems. What is emphasized in geomatics in terms of starting education in this field is learning, for example, the form of the Earth's projection systems. So I want to bring this in terms of technical skills of what we expect from our students to understand, for example, what is the difference between projection systems when you use ArcGIS or similar systems, how you can interpret the data, not just looking the data as numbers. As from your perspective, computer scientists, maybe working with data is essential for sure, but understanding the data is important. So that brings me to rapidly say that in our program, which is called Génie Géomatique, Engineering in Geomatics, what we expect for each course, we have a kind of evaluation of competence. So at the end of the program in 4 years, we expect that our students get that skill. So including in that part is engineering, basic engineering skills, understanding the techniques, technical aspects. And also we are expecting our engineers to be able to understand the problem, you mentioned it, how you can understand the complex spatial or geospatial problem, and then how you would propose a solution and develop a solution. And this development, I would say, in terms of computer scientist perspective, is important also. And then the other competences, which are communication, professionalism, and how you would communicate your results to the others. Having said this, I see during one of the GIS science conferences, there was a panel like here, and we were asking who is an ideal expert on geospatial science that we would need in work market. And we will see, and this is a kind of question for the panel also. As Christoph, you were mentioning, every year there is something new that is added in GIS science. And so it makes it very big. We are expecting our students to understand the difference between projection systems and we expect them to integrate, for example, large language in what they developed as solution for future in the future for solving the problem. So the question for panel is, so how we can frame this expectation of, because yes, it is context dependent, problem dependent, but we should have kind of definition of competence, technical competence that we expect from our students, because you can't be expert in all of those things that we are adding every day in our field. Yes,
Christoph, yeah.
Yes, thank you, Mir, for your insight. I will try to take a sort of metaphor in relation to GIS education or AI education within GIS education. I will take the metaphor of a car. Okay, some people will never use a car. Fair enough. Some people will never use a GIS. Fair enough. Most of us, we use car because we need a car to, let's say, to do some shopping, to go to work. And this might be applied, let's say, to some environmental urban application. We have a lot of people using GIS, but with, let's say, a minimum knowledge just to use it. Nowadays, we do have new cars, electrical cars, and people with a very good knowledge about how it works, they have to adapt. And in the GIS world, we do have to adapt ourselves to sensors, to the way artificial intelligence is coming up, and this is another level. And then you have people, I'm not part of those people, when there is a block in a car, they can repair the car. This is another level. And we do have also people that can design a car. Well, the idea of my metaphor is to show that in relation to GIS, we do have different levels. And depending on those levels, the education needs are very different. The other thing, which is, in my opinion, and this is something to share to my colleagues, the experience I have being involved in many GIS-related projects for several years, every GIS project is a team of people with different expertise. Expertise from the application, can be someone with experience in urban planning, people with expertise in the way of integrating the data, people with expertise in the way of designing the data, integrating data from sensors. Here there is a specific group with strong capability with sensors. And this is something interesting to deal with at the education level. We have to train people, taking into account that the way most GIS projects are pluridisciplinary projects with complementary background. Anyway, maybe my colleagues want to.
Yeah, I would just add something along Christoph's line is that there are, what I have experienced is there are faculty or students who are in different fields, for instance, humanities, right? They don't need to learn a lot of deep understanding of GIS, but they are, we can expose them. So I think one of the things that is, this time I'm taking as a challenge for myself is how can I take two different disciplines and bring them together so they can share. They don't have to learn one skill with the other, but they can at least understand each other and come up with a better product. So I think, and the other thing which I think what Len is talking about is like, if we start geospatial education early on, even before universities, like even in K through 12, that will change the game, right? That will keep pushing the envelope, and then, we might have more core competency that, already baked into students when they, apply for schools.
And I also think that we shouldn't think about only one level of competency. If we can come back a little bit to the second slide that I put, because the definition of a competency is you have the knowledge of something, but you also have skills and you have attitudes towards something. That's the definition, the complete definition of a competency. So we really have to create like different levels, like the basic level, the GIS like basic level, that it's recognized worldwide or in different countries, for example. And then we can have another level like medium or intermediate GIS standard, so that we can teach different things to the people that goes to obtain a certificate. But when you get this kind of standard of competency, you can work everywhere because you have showed that you are able to understand the technical part, but that you also have a certain level of responsibility, and you understand, or you can work in groups, for example. So that's my point with creating this kind of standards that we don't have, at least not in Mexico. And we really need them because we need GIS technicians, for example, that they don't really have to know about AI, for example, or more advanced things. But we need people that understand what a projection is, as you mentioned, or what a coordinate system is, and why my maps are not overlapping because they are in a different projection. That's a very basic level of understanding. So we need to create these different standards, in my opinion.
Thank you. Anybody else, Carla? Want to respond to that question?
I think it has been already addressed.
Thank you.
No. Thank you. It's well, thank you very much for your comments to all the panelists. It's I'm thinking about maybe from my presentation yesterday, you could infer that I'm involved in modeling and reasoning, and I've been working how to use the AI technologies for these two topics. So from the GIS technologies, it's very common that when making the models, thanks to these S3 technologies or other companies, it's able to get some values for the parameters, and we can execute the tools. And this is good news, but also bad news. It's good news because it makes easy to the students advance in the use of the tools, but it's bad news because they really didn't understand and don't provide the right values for the parameters. And usually, the values for these parameters are wrong because they don't understand that the initial values are just raw approximations to them. So in this context, I'm wondering how we could use these AI technologies to provide better approximation to this initial parameterization in order to get better models, and in a second stage, how to help these students to make a better reasoning and not only move from data to information, but doing a next follow from information to knowledge. What would be your opinions about this potential application of the technologies?
Can I address this just very quickly? Because I think this is a question that I always have about the quality of the data. And I think this is an extremely relevant question to think about, because we know that these large or these deep learning or machine learning models are as good as the data they're trained with. So I think if you're working with synthetic data, which I think it's the case because you're predefining or trying to or what you say, approximate some parameters for prediction, that means that you first have to create a very robust simulation model that is able to create the synthetic data. If I understand this correctly, then probably what you can think of, and this is an endeavor that IBM has been doing for, I will say, like for the last 5 years, which is trying to create a AI fairness pipeline, which can help you in the pre-process, in-process, and post-process part of the machine learning pipeline. What I want to say is that there must be a careful curation of data, so you're not including biases or you're not claiming that the data is complete, because we know that no model or no mathematical model or function is going to be complete and consistent. So I think what is really important when we're working with these machine learning models is that we are able to bring the background to conversation, saying the limitations of the data that is either synthetic or the data that is collecting through urban streams or IoT data sensors, IoT sensor collection devices. What I will say is understand that the data will influence the outcome, and if you are able to point towards what's the bias that you've identified beforehand, the prediction won't be so harmful if you haven't addressed that from the very beginning.
Christoph.
Yes, to follow up, I think, Willington, that we do have a big problem. The development of AI and large language model is a big mess. It's a chaos because there is no standard. It's a geopolitics area where the US, Europe, and China are competing. It is industry driven with millions of dollars invest, and it's a chaos. At the education level, the big problem is we don't know exactly what will be in 2 years the level of advancement of these technologies. No way. Nowadays, we have multimodal large language model. They didn't exist 1 year ago. 3 years ago, we had, at that time, very simple large language model. What I want to say is that if we want to design a master degree in GIS and artificial intelligence, the time to set up the syllabus, the time to have, let's say, the degree and to set up the program in a given university will be probably 2-3 years. Then the student will come up and the world will be already a different one. And I think this is a crucial issue. The speed of development is so fast that we don't know what will be available in 2 years. It is industry driven. We don't know how it works because the companies will not let us know how it works. So really it's a chaos. It will be fun. But for teachers, for us, how can we adapt to acquire the skills of multimodal large language model and the way the training model and so on are organized? It doesn't make any sense. So it's a chaos. Sorry to say that, but it's a chaos.
Thank you. Anybody else want to address this one?
I agree with much of what you said. I think AI will have huge implications on teaching and learning, and in some ways, it may require us to go back to some of the basics like critical thinking. It will become more important for people to be able to judge if something is appropriate. Yeah, AI can process huge amounts of data and spit out answers, but it will always come back to the human to make a judgment. Does that make sense? Is that valuable? When we have more capabilities to process more and more information, the thing that will be in short supply is the ability to make sense of it and make value judgments. Should I use this information? Should I apply AI to this or that problem? So there's that piece. And then I think the second piece is, how will educators be able to assess if a student has actually learned something or not, or if they've just used a machine to do the work? I think it will become more important to have good communication skills, to be able to communicate your thinking, your reasoning, and show that, you know, you actually did think through the problem, you understand what the result means, and you can make a value judgment whether to go forward. So in some ways, I think we'll go back to Socratic dialogues as a way of teaching and assessing learning.
Or if there's a way to have a dialogue with the companies that actually make these kind of products and see if they are willing to educate our students, right? So the concept, or even faculty members, so we understand it and then we impart that education to our students. It's a difficult question.
Thank you, everybody. What I'm hearing, right, GIS, science, and systems, it's broad, it's diverse, it's changing really, really fast. I hope this sounds exciting, because this is why I'm in the field. It's probably why most of us who do GIS are in the field. It's hard to think about what the core competencies are needed, because it is so broad and diverse. There are different skill sets that are needed, but can you find those central tenets that everybody should have and understand when you're thinking spatially? There's some uncertainty. Educators are having trouble keeping up with it, right? Christoph was saying, if you're in a 3-year program in AI, guess what? It's going to be completely different by the time you're out. How are students learning when they're using AI? I did want to ask Carla one question. I'll open up to the entire panel yet. Because one thing you had said in your opening, Carla, is within your center, when you get projects, one of the questions you ask is, do we really need AI? And I'm really curious to hear, quickly what your process might be for that decision at this point, and maybe thinking about how does that change a year from now, 2 years from now.
Mm-hmm. So I started my my faculty position 3 years ago, and I was hired as the first AI architect in the department. So I had a lot of conversations with my colleagues about, let's do that just because AI is in the hype and we will get funding if we get AI into this project. So I started being very clear and strategic about what I say yes and no, not only because I was overloaded with work, but also because it really didn't make sense to many of the proposals that I was getting. So what I said about the first time I have someone approaching and saying, I think we need AI for this project, I asked the question, all right, if you didn't have AI, will you be able to solve this problem? And if the question is yes, then why do you want to invest time and resources to build something that you already know how to solve? And I think the other question that I have later when I said, all right, do I need AI? And the answer is yes. Would you like to use AI as a tool or as an instrument? And I bring this analogy to the conversation because I think it's key to make a difference between these two, right? A tool is something made to solve something, and it's very particular, and it's like a hammer, so it is performing well for that particular task. An instrument, on the other hand, it is built to be played, and it's built to be articulating a masterful output like a paper or a violin, depending on how its interaction with the human player, right? So if you think about AI as this type of technology that can be used as an instrument, like a hammer, that it is very accurate, it is optimizing or minimizing or maximizing the specific constraints, or you can use it as a way to navigate and understand a particular phenomenon. What I say is, these two are quite important for our research questions. We just need to identify what is the AI that you need for your project. And I think if it is an AI that needs to be precise, accurate, and fast, then we have the resources for that. If you need an AI that is helping you navigate the space or helping you point towards directions, we have the AI for that. So I'll say, think whether you need AI, and the first question you ask is, if I don't have AI, can I solve this? If the answer is yes, then you don't need to go to that path. If the answer is no, then you can think about whether it's a tool or it's an instrument, and then you can navigate that way as well.
Thank you. Tim?
Yeah, I completely agree with Carla's statement. I think there is also a hype factor in here too, like AI. I want to implement AI on my employees' satisfaction or whatever, and it's not even necessary. Right? So sometimes people just go after funding by using the word AI. You really have to think it through. I think if you have to design it from the core, if you want to implement AI, then it has to be properly evaluated.
Coming back to what you were saying, Angela, I do believe critical thinking is essential. Probably 95% of the questions prompted to ChatGPT are straightforward questions. And probably we don't really need ChatGPT to answer straightforward questions. But when we are prompting, let's say, a straightforward question to ChatGPT, the question is transferred to a big server somewhere in the US, CO2 emission, and at the end of the day, there is an environmental impact. What I want to say is that critical thinking is really important because, let's say, when someone is doing a research paper using AI, there is often a few critical evaluations if what they did should have been done with another way. Yesterday, I presented a map generated by a large language model. It was really straightforward, just showing a map of US pharma expenses and so on. We can really do that with a basic GIS system. Come on. And most of the things done with ChatGPT, and probably nowadays, and this is something we should be cautious, critical thinking, avoiding using AI for basic stuff. And fortunately, I do believe that we are likely to go in a world where AI GIS, 90% of the application research paper will be basic stuff. And we don't really need that. So critical evaluation, and we do have a responsibility of that. But I'm quite skeptical about that.
Thank you.
Can I add something to this? I think the idea of the critical thinking can be rendered into, asking, I will say, right question. I always hate this term about right and wrong, but at least knowing that AI will answer anything you prompt it with. So then it puts a lot of responsibility to have this critical thinking and this ability to articulate meaningful questions. When I say meaningful questions is understanding that there is constraints, that there are actors that have needs, and these needs need to be fulfilled within the question that we have. So I have this conversation with my students when I say, right now, text and images are almost for free. They are very easily achievable. So when they send me a 20 pages long text for one idea, I don't even look through it because I said, if you're not able to articulate a concise problem statement in one paragraph, I don't want to read anything else because everything else is going to be something that I don't think you haven't even looked at. So I think that's what what will move forward with this idea of AI is that we have to be more concise and kind to the people we're sharing knowledge with, because now we know that text, like I have this joke that says, I use ChatGPT to write this email, and then the person that gets the image uses ChatGPT to get the tasks, right? So why don't we just limit this translation and just be straightforward to what we want to do and be concise and have critical thinking?
Christoph.
I remember well, coming back to the history, in 1980s, there were a big boom. Expert system. Everybody was talking about expert system, panel about expert system, logic, reasoning, and so on and so on. And after 5-10 years, It will be interesting to see in 5, 10 years if this happen to or not to AI. And 20 years ago, it was the same about telecommunication. And then the industry of telecommunication was slowing down. So there is probably a risk to take into account in education program. But what is going on with large language model is likely to be as well, or not, but there is a risk. Maybe we will discover that it doesn't make any sense to use those expensive system to reason, because we don't know how it works. It is industry-driven. There are some geopolitics issues in behind, and at the end of the day, maybe we can do better things without AI.
You know what I think the next 10 years will look like, and I would like to entertain this idea, because what I'm seeing currently is that we are living in these echo chambers. If you're thinking about the geopolitics, right? So my social media or the news that I get are curated for my profile, and this is something that I cannot control. So what I'm seeing that could be a future, I'm intrinsically positive. So that's my plain answer to you. I will always try to be positive, is that probably with this large language model approach, we're able to break this echo chamber, because we are not going to be curated for that particular profile that has been trained with our interactions with the web. I think that could be something interesting to think about. How can we break from these existing constraints that these companies or the government has put on us, just to see a little bit more farther? And I think that could be something that we can, not, I won't say fight, but at least try to push in the classroom, in the research project. How do we break this constraint?
Thank you. That's actually a really good place to probably stop, because we've gone through our time. Is it quick? Yeah, all right. Here we go.
While you were all talking, I was thinking that we really ask ourselves the question that is it the I was thinking that maybe actually us as educators, how we are valuing results produced by AI from our students than other research done. For instance, like if a student is training some algorithm, producing results that are of course interesting, then there are
Sorry, you're still breaking up.
repeating from the beginning, or?
I think so, yes.
Okay. Well, I was thinking that how the results produced by AI by students are appreciated than maybe other types of research done by students. So for instance, maybe if a result's done by AI, then the student is invited to do department seminars, like the work is, I don't know, maybe published in LinkedIn page of the school and so on. But then sometimes in geospatial field, we were talking about that geospatial field is now impacting, I don't know, health, environment, and everything. And we are working, for instance, mapping health data, which we are working with data from the public. So it's important to be interacting with the public and everything. So what if a simple survey is done with, for instance, citizens and public? Is that as much appreciated as the mapping that is done by AI? Do we need also to give value to this type of research, or is it like maybe us that are more giving value to the results produced by AI? I think we are talking a lot in panels, discussions about we need to, I don't know, we should not be too much dependent on AI, but at the end of the day, I feel that we are also giving too much value to the results produced by AI. And so the question, how we can actually integrate these social aspects to geospatial education, which I think is very important and maybe is not that much integrated.
Anybody want a quick answer? Okay.
I have an answer as well. And I think the idea of capturing human perception or these qualitative aspects into, and then how to relate them to qualitative or hard data. It's really hard because even what I think it's like let's go back. Everybody creates a model of the world in their minds. So what I'm thinking and how I'm encoding reality, it is different than anybody else in this world. So we came up with tools like language and like the alphabet and like mathematics, so we could communicate and encode our thinking as to have us being understood, right? So if you're trying to collect a perception of a human that is not relatable, it's very hard. And when we're trying to do this, for example, I have an algorithm that is trying to create a ChatGPT for structural design, which means that you type down what you want to design, like, for example, a bridge that has a particular typology, a particular length of a particular material, that it looks large, that it looks like a tower. So those things are things that are really perceptual. So how do you capture that? And so one way that I will say is that you cannot do it through one layer of labeling. You need to do multiple ways so they overlap, and then you have a robust way to understand what is big, what is large, what is small. So I'll say human perception, or at least capturing human qualitative data needs to be in a layered process. So only one approach to capture shouldn't be enough. It needs to be at least 3 or 4 attempts through different lenses to be able to capture this qualitative data. I hope I understood the question. Is that it was very hard to hear, but I hope this helped answer it in any way.
Thank you. Yes. Christoph, Miriam first. All right, really quick because we are over time. And then we'll go to Christoph for the last word. It is.
I just want to talk to all the students who are right now freaking out, thinking that it's really hard to make a career in GIS. It is not. I love when the students come and they know zero about GIS, because that is my favorite way to start teaching GIS. I was not good at technology. I was not good at coding. You can make things happen, but one thing I would tell you, and I don't want to sound like a mother, but even to ride in a board, on a skateboard, you have to practice. So when students come and say, I'm terrible with technology, I just said, how many hours you have invested on this? And if it's 1 hour, of course. But if you instead of spending 30 hours on Instagram and 3 hours in your homework, maybe swap it, and it happens. I promise that it happens. Just don't be afraid of everything that has been told here about AI and learning all this, but rather be smart how you use your time. That I just want you to, if you were getting anxious, just don't worry about it. Just work hard.
Thanks, Miriam. 30 seconds.
Just a second. I will make another provocative statement. The difference between GIS and AI is probably that in a few years, nobody will be talking about AI, one, but everybody will be talking about GIS. We should not overestimate artificial replication of data from fuzzy data. We don't know how it works, but it provides some, let's say, summarization of data. It's a bit stupid. It's nothing about artificial intelligence. And I really believe that in a few years, the hot topics will be different. It will be about quantum computing. It will be about robotics. And we'll be discussing here the way robotics and quantum computing, much more exciting than artificial replication of stupid data, messy data. We don't know how it works, but it provides something at the end of the day, and we have the way of interpreting the information and explaining why we do have this result. So anyway.
Thank you. Thank you. All right. We're going to finish. Thanks to our panel. Thanks to our participants. Thanks to all of you for listening. I hope we answered some questions. I think we created more questions, right, than we answered. But this has been fun. A big round of applause for everybody. Carla, too.
Is this your mobile? Thanks a lot for all the wise words. We are very glad of having you all here. And now we are going to acknowledge all the hard work that you made here. And we want to begin by giving the acknowledge to our moderator, Lini. Can you please come to the middle of the scenario for taking a picture? And please give him a very big applause. Now, following up, we are going to acknowledge to Diana Castro Frontana. Can you please come here? Applauses. Now we're going with Christophe Clarmut. Can you please come? Thanks a lot. Now we're going with Angela Lee, please. Him Mystery, can you please come? Thanks a lot. And dear Carla, we are going to be sending you your acknowledgements. It's a pleasure to have you here. And now can all of you guys please come to the middle for taking a group picture? A really big round of applauses, please. Great, thanks a lot, and another round of applauses, please.